Ahoy hoy, I'm PlanetWalk, and today we are responding to Flatzoid responding to me. There's a part 1, so if you haven't seen that, that will probably have quite a bit of context for this. Especially seeing as it will explain why he gets so mad at Baffy. Well, explained as much as flat earthers can be explained. Anyway, where we left off, Flatzoid had just finished out reading some of my comments, for whatever reason, and is now actually getting back to responding to me.
Okay.
But let's say that you're operating on a different kind of perspective. Okay, well, how...
Operating on a different kind of perspective? What the bloody hell are you talking about?
I'm talking about how flat earthers will often try to say that perspective will make things disappear bottom first, even though that's not what it does. How does that perspective work, and how does it differ to what we would expect to see on a globe?
There's no such thing as different perspective. What the is this talking about? Last time I checked, perspective is perspective.
Okay, in that case, then you would have to agree that perspective does not make things disappear bottom first. If you disagree with that, then you are using a different version of perspective.
By the way, guys, hit the likes, share the show. Let's get this out to a wide audience. Let's show the people just how dumb the globe defenders are.
Hey Flatzoid, I don't think that's what people are going to see when they see your video, unless they're flat earthers. The Rayleigh criterion and the angle of attack explain why things disappear bottom first.
Yes, it does. Yes, it does. I think from now on we shall talk as if we are gentlemen, because that makes us sound somehow ignorant to this buffoon.
Okay, I'm not sure how they got gentleman voice from that. If I wanted to do a gentleman voice, I'd go, the Rayleigh criterion and angle of attack. Instead, you got the Rayleigh criterion and angle of attack. But as I mentioned in the previous video, whatever voice I use is irrelevant. It's just a way to differentiate my arguments from the flat earth arguments.
So from now on, PlanetWalk, you shall now call me Tim.
Okay, whatever you say, Little Timmy. And I will be calling you that as well.
Or how about Sir Henry?
Nah, I'm gonna stick with Little Timmy. It seems a bit more appropriate to me.
What is wrong with this guy?
He's not. He's nuts.
You know what? I think PlanetWalk, lay off the vaginal cream and get yourself some protein shakes.
Okay, I'll admit, Little Timmy has bested me with that one. Because I don't know what that has to do with anything. Like, what does that have to do with my argument? Maybe it relates to my voice. What does it have to do with my voice? Like, I can kind of get that he's trying to say that I'm weak and need to be stronger to be more of a man. But, like, just say that I need to get in shape, as in a 3D shape, rather than a 2D one. See, I can come up with an insult towards me that's, you know, coherent.
Yeah, Jolly Man, we all pictured that satanic teddy bear straight away. That was the first thing we all saw. And to me, that is, if you give your children that is literally just wrong.
I am still shocked at how much he tries to moralize having a Baffy plushie. You know, he might as well moralize about this, having a black cat, because, you know, witches have them and you might indoctrinate your kids into witchcraft or something silly like that. Actually, we probably shouldn't give him ideas. Well, no, it doesn't. The Rayleigh criterion just shows when something will become unresolvable.
Oh, really? So, like, when the ground is more resolvable than the bottom of the object, which is really oddly based on 1.22 times the square root of the observer's height in feet. Well, Rayleigh criterion is based on the lambda, the lambda of light, but it's also based on 1.22, so it's weird how that correlation stems.
Okay, so what he seems to be thinking here is because 1.22 shows up in the Rayleigh criterion and 1.22 shows up in the distance to the horizon in miles, then somehow they must be related. And the only reason it's a coincidence is because you're using imperial. If you're using metric for the distance to the horizon, then it's 3.57 times the square root of the observer's height in meters. But when it comes to the Rayleigh criterion, it doesn't really matter whether you're using metric or imperial, the 1.22 is still going to be in there. And because of that, these have nothing to do with each other.
And then note, we have how many channels now all over the YouTube land and over the internet where we actually demonstrate bottom-up obstruction on flat surfaces?
Except every single one of them has a problem, from not knowing how lenses work to not using a flat surface.
And that's not to mention the globers that try to debunk us and then demonstrate our actual claims for us. and then say we're wrong while they demonstrate what we said.
I have not seen any examples of that happening. Is it potentially that you don't understand what the globe earthers are saying, so anything that we do say, you can just go, oh, well, clearly that agrees with us?
I can't say the other people do demonstrations though, so yeah, you guys just talk.
Well, there is an importance for talking. If I showed you, let's say, this picture and I told you to debunk it, the way that you're going to debunk it is not with any actual demonstration. You're going to debunk it by talking. And also, that is what Flatzoid is doing. He's talking. If the top half of something is resolvable, then there's no reason why the bottom half shouldn't be.
Oh yes, it should. I'm going to quickly draw it for you on paint. Can I explain it to like you would explain to a 4-year-old?
Okay, Little Timmy, listen. You're in no position to use that kind of condescension towards me. You have been catastrophically wrong in the stream that you're doing on really basic things. Do I need to remind you that you don't know what foreshortening is again?
You have one peak of light like this. Look at mountain, child. You see? This would be the one resolved object. So at the moment, you are able to resolve 2 different objects. We take this one and we move it closer. Still resolvable, but it's quite blurry next to each other. Now what happens when the maxima and the minima of the two, that would be the maxima, that would be the minima, overlap each other like this? Would you be able to see 2 objects or 1 object? I know, 1 object. Now, let's for instance say boat on the ocean floor. You are able to resolve the boat and the ocean.
Okay, so the fact that he drew what he drew for the boat shows not only that he has no idea what he's talking about, but also displays an inability to think in more than 1 dimension. So, Little Timmy, if you're watching this, and I kind of doubt you are, but I want to ask you a question. So let's take the boat in the image and say that it's getting further away from you on a clear day. Which part of the boat should disappear first according to the Rayleigh criterion? I want you to really think about it. Now, I already know Little Timmy's answer because he answered it in the video, but if he's watching this, he gets a chance to revise his answer.
What happens when that boat moves away and the angular size becomes smaller? The boat's angular size gets smaller, correct? Does the water's angular size get smaller? No! So, let's quickly draw this out in an orthographic type of way. The maxima and minima of water. This would be the ocean. Let's just O for ocean.
Okay, little nitpick here. He's not really drawing it out in an orthographic type of way. He's just, like, visualizing the Rayleigh criterion badly.
So the boat is going out and it's becoming smaller with distance. And it's getting closer to the angle of the water. So the angle of the water stays exactly the same. The boat going further away is going to say, what does that say, class?
Shit shrinks.
There we go, shit shrinks. So which one is going to be less resolvable? The shit shrink one or the one that stays the same size?
I would wager that it's whatever's smallest, but there is something in that scene that you have neglected to mention that is also staying the same angular size. Wonder if you can figure it out.
And because shit shrinks in the distance, what's closer to the larger angle? The bottom of the boat or the top of the boat? Let's put it this way, Globies. The bottom of the boat is closest to the largest angle, which is the sea.
Yep.
So you have the what we call the diffraction limit. You are now only able to resolve 1 object.
Okay, so even according to Little Timmy, you'd still be able to resolve 2 objects. It's just that part of an object would have disappeared, though he is wrong on that. You see, for all he's been saying about different objects and stuff, there's a 3rd object in the scene that he's neglected to mention. And it's quite common if you go outside. It's called the sky. Now, I know, technically not an object, but for the purposes of the Rayleigh criterion and what Little Timmy is talking about, we can treat the sky as an object here. The first thing that would become unresolvable in his example there is not the bottom of the boat, but the pole holding up the sail, because the pole holding up the sail has the smallest angle on that, and it's right next to the sky. That boat isn't going to disappear bottom first. In fact, according to the Rayleigh criterion, no boats should disappear bottom first. Because if a section of the bottom of the boat is unresolvable due to the angle being too small, then the same size section at the top or sides should also be unresolvable. And that's not to mention the small details of the boat, which would become unresolvable against the rest of the boat.
I don't know if there's really any actual genuine ballers out there that... Because I think they literally just punt the globe because they have to at this point.
No, we just understand this a lot better than you, as much as you don't want to admit it. Your lack of willingness to understand is what's keeping you as a flat earther. And because you don't understand the things that I'm saying, you don't understand how I could be genuine. You can actually try to simulate this by scaling an image down. You see, when you scale an image down, it loses a lot of the resolution that it has and a lot of the finer details.
Yeah, but when you've done that, did you notice that the whole image is losing resolution? Not just the buildings alone.
Yes, but it does give an accurate example of how the Rayleigh criterion might affect this. The detail that you see getting lost here would go far before the bottom of the buildings disappear.
Last time I checked, when you're going with a boat on the ocean and you're traveling further away, the sea doesn't get smaller in angular size like your boat. It stays the same.
Well, in the example that you're responding to, the buildings aren't moving. The viewer is. And that means that everything in that image should change angular size. Objects don't go over the horizon because you can zoom back in on them to bring them back into view. Well, whenever I see someone try to zoom in on something to bring it back into view, it's because it's just gotten too small to resolve without zooming in on it, not because...
Oh, so resolution limit then?
If by that he means there aren't enough pixels, then we agree on something.
No, I don't think this guy should do impressions. It's quite bad.
No.
Especially if his impression... I think he's doing the impressions to try and hide the fact that he absolutely knows nothing.
Every time I do the voice, they just complain about it. At some point, you have to acknowledge that it's just a thing. Like, this point, I'm probably going to acknowledge that you complaining about my voice is just a thing at this point. I've never seen a flat earther bring an object back into view that has disappeared bottom first over the horizon.
Really, I have an actual video on my channel. One of my first videos ever. I've shown it live how many times?
Is this what you're talking about, Flatzoid? You know, because if it is, it's a direct example of what I was talking about.
There's nothing on the horizon. You zoom in. Guess what? You see the thing again and it comes bottom up.
Okay, show me something that zooms in on something and you see the top first and then the bottom reappears.
And by the way, when you have something like an ocean, there's things called waves and bulges. I mean, we can show videos of boats not even at the horizon disappearing or bottom up and showing again because of small waves and because it's going in and out of the crevices of those bulges.
Well, that only works as an explanation when the observer height is low enough and the boat is big enough. If both the observer height and the height of the boat is over, let's say, 2 meters, then the waves themselves would have to be 2 meters to hide the boat. Gas pressure cannot exist next to the vacuum of space without a solid barrier because otherwise all the atmosphere would get sucked off.
That's not what we say. We tell you this. Gas requires containment. Without the containment, there can be no pressure. What is gas pressure, you may ask? Well, it's simple. Gas moves and hits surface walls. This, my friend, is called gas pressure. What does that tell you? If there's no surface wall to hit, there's no gas pressure.
So the argument that he's using there is a weaker argument because some of it is technically correct, But it doesn't lead to the conclusion that he thinks that it does. Because yes, to have pressure, you need something that's being pressed against, otherwise you don't actually have any pressure. However, this is just a quirk of how we define pressure, and does not lead to the conclusion that gas pressure needs a container. The only conclusion that you can draw from this is that you need to have something for it to press against. And we have that thing on Earth, it's called everything on the Earth. It doesn't need to press against something in all directions, it just needs to press against something.
What gas pressure literally is gas hitting surface walls.
Well, not just surface walls, but any surface, really.
Now you can have gas just moving, but if it's not going to physically have that action of pressing against the container wall, there's no pressure.
That is kind of true if we replace container wall with just surface, but that doesn't actually lead to the conclusion that a lot of flat earthers try to get at, which is that Earth apparently needs to have a dome in order to have an atmosphere. It completely ignores the fact that as you get higher in elevation, the air pressure decreases. So logically, if you get high enough, you're going to find yourself in a vacuum. Water finds its own...
No!
Wow.
As Del says, no!
Hey, Del, is that how you say it?
No!
It's very simple. The higher you go up, the less air pressure we have in the same system. Pressure gradients comes after pressure, which comes after containment.
Well, no, that's not how it works at all. We're discussing whether the Earth is covered in a dome or not. Now, if we completely ignore the fact that space agencies have gone to space, because I know Little Timmy will disagree with that, then we have no direct observation of the dome or of a vacuum in outer space. So in order to conclude what's up there without actually going up there, we need to use inferences. Now the inference that flat earthers use is that gas expands equally in all directions without a container, so without a container, well then it will just keep expanding forever, and thus Earth would lose its atmosphere. However, one of the things you have to do is you have to work out, okay, this is true on a small scale, what else would we expect to see if this is consistently true everywhere? Well, one of the things we would expect to see is air pressure being roughly the same pressure on the top of a mountain as it is on the ground. But we do not see this in reality, we instead see a pressure gradient. And there's no reason why this pressure gradient can't continue until it's a vacuum. Flat earthers have not provided an answer for that.
We have the gas there, and we have Earth there. This is the ground. Now, this gas particle bounces. Okay, is there pressure there?
Yeah.
Okay, now the gas molecule bounces away. It's in this direction.
Yeah.
Where's it coming back?
It's not unless it hits a container.
Unless there is, some other force that brings it back, like, I don't know, gravity maybe? If gravity exists, then that particle will return to Earth. That is what gravity does after all.
How is it that we are able to say the gas is coming back to breathe?
Hey, Little Timmy, I'll give you a hint for the test. It's gravity, that's the answer.
Molecules that's literally bouncing everywhere in all directions constantly. And it can only change direction with what?
Collision.
A physical collision.
Well, any force, really. It doesn't have to be a collision with something. A collision is a force, yes, but it's only one type of force. Water finds its own level, meaning that it will always be flat and will never take the shape of a globe.
Whoa. Also, say it correct. Water, according to physics, always finds its level when seeking rest.
I mean, my argument will still work because I didn't talk about, waves, because I know that flat earthers say that waves don't count.
When at rest, correct?
Yep.
When at rest. It's a very, very specific thing to say. When at rest, which you never seem to say, any anti-flat earther on the internet.
Okay, I get it. When at rest, when at rest, when at rest. My argument will address when at rest. And surface tension doesn't count.
Back to the paint. Let's have a little syringe. Mr. Planner Walk. I know you don't like that, but I'm going to say it anyway. Mr. Planet Walk.
I mean, you've been intentionally misgendering me all stream. If I was going to flip out at you, it would have happened by now. And I know you're doing it just to be a dick, so, you know, I don't mind being a dick back, little Timmy.
So, I mean, like if you have a little water droplet, you would agree the surface tension is okay, because it's small body of water. There's not a lot of force. Most of the force is coming from around it, because there's forces always acting on it. In this case, gas hitting it. So the gas hitting and going around from all directions. The gas hitting in all directions.
Don't you think then that there might be a good way to describe the shape that water takes under all circumstances, not just particular ones? This way we can add nuance to stuff. We can say, oh, this is why a water droplet is round. You see, I figured out the description to use years ago, way back in 2018, and the answer is, it conforms to the forces acting upon it. This means that if there are forces acting upon it that makes it take the shape of a ball, it will take the shape of a ball.
What happens if I add another water droplet to that water droplet? Would it still be a water droplet? Would it still be round? Does that look round to you?
Not really.
What happens if you add even more water? Does that look round to you? Or how about we've added even more water? Definitely not round. Last time I checked.
I do have to say, I like how I said surface tension doesn't count, and now he's going on this big long tirade about how surface tension doesn't count. It's basically just restating what I said, except using a lot more words.
Because the surface tension is based on surface area.
Exactly.
So, the larger the surface area, the less force attributed on the area. It's displacing the pressure evenly, so it's becoming less force acting on it.
Well, no, not quite. With more surface area, there is more surface tension. It's just that there's a lot more mass. Now, the more mass you have, the less, let's say, effective a force can be. Now, let's say that there is a force acting upon the water that is proportional to mass. Now, as the mass of a water droplet grows, you're going to see this force have more and more of an effect compared to surface tension. Even though the surface tension may be higher than it was before, the force created by the mass is a lot higher than it was before.
So, if Planet Walk is trying to argue that the ocean of the Earth, of the globe, quote unquote, is kept together because of surface tension, the guy's a complete and utter nutter.
Well, no, that's not my argument, though I could make an argument involving surface tension, if you want, because you recognise that a force can make water spherical, i.e. surface tension, so why couldn't other forces make water spherical? Neither do waves. So the first thing that this argument ignores is the fact that tides exist, meaning that sea level will change.
Yeah, tides exist, great. Absolutely got nothing to do with if water curves or not, by the way. Remember when I said at rest?
Okay, in that instance you can't point to the oceans being level because, well, they're never at rest. Change over the course of a day, and high tide does not occur everywhere at the same time, so...
Some places never have a high tide. Ever thought of that? You ever heard of nodal tides?
Yes, I have, but that doesn't change my argument. Just because some places don't have a high tide doesn't mean that all places don't have high tides. There are still places that have a high tide, whilst in other places having a low tide.
Your diagram was an idealised example.
Yeah, it was just it was a simplified version, Andrew.
Exactly.
Because sometimes we have to go so rudimentary for people like this that they literally don't understand the basics of logic and physics and reality.
Flatzoid, that is really rich coming from you. You've got these diagrams and whatever, and sure, sometimes they're okay, but you never actually do any maths. Even when maths would be ideal for you to do. If we want to say, okay, ships do disappear bottom first over the horizon on a flat Earth, then show me the maths. I assure you I can handle it because I do programming. Maths is like a core part of that.
So we have to go so basic that even if you're deaf, blind, and dumb, you'll still know what's going on.
I don't buy that, because you haven't shown that you have a higher understanding than that of what you're presenting. The reason I don't accept your arguments isn't due to some lack of understanding. I understand your arguments perfectly fine. I don't accept your arguments because you haven't given me good enough reason to accept them. But more importantly, saying that water always finds its level
At rest.
is oversimplifying the shape that water actually takes.
Water takes the shape of its container.
Okay, but that is an oversimplification, because obviously the top of water isn't taking the shape of its container because, you know, it's not exposed to a container.
Okay. Hello, Mr. Planawalk. Here we have different containers.
Oh jeez, it's using Bing. Flatzoid, just a bit of advice, please learn how to change your default search engine. Trust me, it makes things a lot better when you do it, and I'm not even telling you which search engine you have to choose, like just not Bing.
There we go.
Yeah.
Different containers, correct?
Yeah.
See
Always got to be level.
The water level. Do they
Doesn't
draw the water level curved?
No, never.
Well, that's because the curvature over such a short distance is, well, negligible. And also a lot of these drawings don't account for surface tension because maybe they're irrelevant to what's being talked about.
Well, how about yeah? That one side is the same as that side.
Yep.
Really odd stuff, don't you think, guys? Weird how that works.
Okay, but how does it work? Why would water become level like that? Is there maybe a force acting upon it, would you say?
Water and gas both require containment. The one is bonded, the one is not. But one thing we do know, they both require containment.
Okay, this is where his oversimplification is really not going to work for him, because what does he mean by containment? Does he mean solid containment? Because if he means solid containment, well, the top of water is not contained by a solid. Now, I could give Little Timmy the benefit of the doubt here and say that maybe something else, but I'm not going to do that. If I do that, then I'm basically just giving him an answer for free. No, I want him to explain what he means. Because if he can't go into any more detail about what he means, he's not just dumbing it down for me. He's just saying all that he understands.
Water seeks level when at rest.
Hold on, it's taken me a bit to notice this, but that statement is kind of oxymoronic, don't you think? Because if it's seeking level, then by definition it's not at rest. Though what he means here is that water at rest will be level.
And if you want to claim gravity, you can't. Gravity's not a force.
Well, you can use gravity as a force. Cry about it all you want, but that doesn't change that fact.
And if you even gave it as a force, it wouldn't even be strong enough remotely to do anything.
Okay, maybe do some maths on that. I'll even give you the equation for gravity. A better descriptor would be water conforms to the forces acting upon it. Thus, if there is a force acting upon it to make it curve...
See what I'm saying? And what force are you trying to say here, Mr. Planawalk?
It doesn't have to be any particular force. If there's a force that can make it curve, it will curve. Then yes, it will curve. Gravity is just...
There's no such thing as curving water, Planawalk. Water takes shape of its container. No container, no shape to take on. Get it?
Well, except for when it's a water droplet and when it's not at rest, and when the container is curved, then obviously it's going to be curved. Basically what I'm saying is that Flatzoid is wrong here. He acknowledges that water can curve, obviously, but he just doesn't think that it can curve on large scales. And when it does curve on large scales, it's just not at rest enough, apparently. Anyway, I'll leave it here for now. There's about an hour left of this 2-hour stream to go through, so let me know if that's something that you want to see more of. Do I have to suffer through more of this? Maybe I should see if FTFE wants to go over the rest of it on a stream or something. Anyway, leave a like and subscribe if you like this video. Leave a comment letting me know what you'd like to see me do for future videos. As always, a big shout out to my $20 or more patrons: Hugh Jarsz, M.C.Nutkin, Morrie, Vermont1777, Tony C, Rosyna Keller, KidVicious, Sacha Campbell, definitely not NASA, Craig D'Amelio, Richard M Chapman, Kaylee, and FistWizard. If you want to support me financially, you can do so on Patreon. There should be a link there, or you could buy me a coffee. I will see you in the next video. Between you and me, thank you for watching.